Today on this GE Profile dryer, I'm first going to go over some components, the components location, their purpose, and then we're going to go over the schematic and talk about a little bit how to read the schematic and how to use it for troubleshooting, okay? First of all, this is just a layout of air circulation. Air circulation is important for dryers to dry. Why? What's the importance of air circulation in a dryer? Yes.
To give your clothes proper drying.
Okay, but how does air circulation do that?
It's basically the mechanism that transfers the heat to the clothes and then removes the moisture out.
Okay. So it puts heat into the air and removes the moisture from the clothes, but also the air coming in has to be dry air. For example, you can see here, this says exhaust, and it's blowing out the back of the dryer. Well, that's hot air, right? So can't I just suck that hot air right back in and go back over the clothes again? Why? It's hot air. It's already been heated and going out the back of the dryer.
I think that hot air, that hot is not staying, it's going out, no?
Yeah, but if you look, the inlet air is coming in through vents on either side, right back in where the hot air is coming out.
Because the blower that we have, a sock and bush, is not gonna recirculate the hot air.
No, it's going to circulate the hot air out, but is it good for that same hot air to go right back in the dryer again because it's hot?
It would make it a closed system.
It would make it a closed system, so to speak, but air is like a sponge or a towel. If you had a big puddle on the ground and you stuck a sponge in there, would it take the water out?
Yes.
Okay. But if I picked up that sponge, set it on the table, then take that same sponge and stick it back in the water, how much more is it going to absorb? So the same thing happens. The air coming in has to be less moisture in that air than the air coming out, or otherwise it won't take the moisture out of your clothes and it'll extend your drying time. So if someone has a dryer in an air-conditioned home, air conditioning takes the moisture out of the air. It doesn't just make the air colder, it dries the air, okay? And a dryer heats it up so that the moisture in the clothes turn to moisture in the air, and the clothes do that. If you recirculate that same air, that air can't hold no more moisture. Now, if you take that same dryer and put it out in the garage, it's sucking air from outside, but we're down here in Florida. What's the humidity level all the time? 80%, 90%, 100%? So you're taking that air from outside, you're heating it up, but the air already has a lot of moisture in it. So will a dryer dry the same towels at the same speed if it's in the garage or in an air-conditioned house?
No.
No. So if it's in an air-conditioned house, it would be faster or slower?
Faster.
Faster, because there's less moisture in the air. Okay? So air circulation is very important. Do I need to know when I'm working on the dryer how it actually flows to the dryer? Somewhat. Because we need to know that for troubleshooting purposes. Right here in the front, what is normally located right here? Well, this is the door and the filter.
Yeah.
So in the front of this machine, we have the filter, right?
Yeah.
Goes right in here. If I take the filter out, we got a big opening there. What could happen? What would I do? Hit the button here? What could happen if I take this filter out? Clothes can fall down there. Clothes can fall down in there. Socks, underwear, something like that. If something falls down in this intake, it's going to go right in your fan.
It's going to blow.
They can either break the fan, it can block the air circulation. If it blocks the air circulation, problems can happen, and we'll talk about it as we identify the components. There's seals around the front and the back of these drums. If the seal's bad, will the dryer dry as good as it's supposed to?
No,
Why not?
it's not gonna
The
hold
compression.
air, so it's gonna.
Well, let me ask you a question. Here's the drum. Right? We got holes in the back and this big opening in the front. The air comes through the heating element in the back, comes into the drum, and as the clothes are tumbling, the air's flowing through it, goes down the filter in the front. Is the drum positive or negative airflow?
Positive.
Well, what does positive or negative airflow mean? You
You
said it. You said it, but do you know what that means?
It's not like the wire, it is the negative, positive.
But it is negative or positive.
Yeah.
The
Because
positive.
you have the sense, you have the sense.
Well, no, but what I mean by positive, negative airflow is if it was positive airflow, that means the fan would be blowing air into it, putting it under pressure. Negative airflow is like a vacuum cleaner. It sucks the air out of the drum. It's pulling air from the back side, but instead of blowing into the drum, it's sucking out. And in this case, this fan is here, the heater's in the back, so air flows out of the heater, goes in through the holes in the back of the drum, over the clothes, and it gets sucked here, so we're in a negative airflow. Okay? Now the seal that goes around this drum, if it's bad, will it blow air in, or blow air out, or suck air in?
What would be happening?
If this seal is bad,
Yeah.
would air blow out, or will air get sucked
Blow
in?
out.
Sucked in.
Sucked in.
Exactly.
Because it's
Second.
negative airflow. So here's the problem. If you have a bad drum seal and we got this negative airflow, we're supposed to pull air over the heater in the back and come in, but now I'm pulling in air from here. So what's happening to my air back here? Either it's stopped or it's not enough air and I overheat my element. If I overheat the elements sag. We talked about this just a minute ago. The elements don't get enough airflow, they start to sag, and then they break. And you can identify that when you look at the heater housing or the drums, they'll look burnt. The metal discolors. And when you see that, either you have an airflow problem in the machine, or the hose in the back is blocked, not allowing that air to flow. And if we have airflow problems, we have drying problems. So when you go to someone's house, it's not always something broken in the machine that's going to stop the machine from working. So the airflow could stop the air from flowing over the drum, over the clothes, over the heating element, etc. Go tell Simon about that. So,
Oh,
If the filter look good also is the same thing.
well, tell me what you mean by the filter not being good.
Well,
Has it got a hole in it?
Yeah, it broke in it clogged with the dirt.
If it's blocked with airflow, it's going to sit right here. It's not going to suck the air in. The fan's not going to work.
So
Okay? So that's going to cause a problem. I'm going to tell you right now, you guys, when you dry clothes, your lint filter catches with lint. Lint filters only catch 10, 20, 25% of the lint that comes through it. The rest of the lint gets blown out. It goes into the pipes in the wall, it blocks the vents going out the house. This here only captures some of it. You know, you really don't need a lint filter on the dryer, just let it all blow outside. But then it makes a mess everywhere, so manufacturers put a filter in there. It don't need it. It doesn't help in drying the clothes at all. What is lint? What is lint, where it's coming from?
From your clothes.
How is it coming from your clothes? Because I put this shirt in and I take the shirt out, it's the same shirt.
Isn't it also dust from the air?
Very little dust from the air. He's right, it's from your clothes, but whenever you wash and you dry clothes, you're rubbing the clothes together. Now you've all seen someone take sandpaper and go on wood and it leaves that dust. Well, the dust of the wood is still wood, but it's in dust form. Well, your shirt's made out of cloth or cotton, silk, or whatever, and when they rub together, small little hair fibers of your clothes are wearing down. The more lint you see in here, the more it took out of your clothes and wears your clothes out. So, do we need a filter? No.
Now let me ask you this. As you said, it works as a negative pressure. Now, the air goes through.
So it's sucking air this way and then blows it out there. So the only positive pressure is after the fan going out.
Yeah, what I was saying that that all this lint will not stay on the blower and make it like unbalanced, or if you didn't put the filter.
It could, because that air is filled with moisture and, you know, it could stick to the fan. But like I said, the filter is only 10-20%. So what's the difference if you had 70% passing through or 100% passing through? You know what I mean?
It probably helps more just to keep something big from going into the fan then, right?
Probably. But they can control that through the opening on here, on the filter housing. If you make these openings smaller like a filter, why put a filter? Because it's going to stop big things from getting in anyways. You know? You've drawn on the diagram. Pass it around. Alright, so that's just important to know when you're working on a machine, because airflow not only affects how it dries, but the controls that are in the system that control temperature, control the dryness of the machine and everything else. If there's an airflow problem, then those controls won't control it properly either. Okay? So let's go through. You all have this book on your jump drive, and I'll upload it and attach it to the video. Here you can see the machine, basically the same machine we have there. We have inlet control thermistor, inlet safety thermostat, high limit thermostat, outlet control thermostat, outlet control thermistor, your pulley, your motor, and your blower, and everything else. There's not a lot of things inside this drive. It's not filled with 1,000 parts in there. But let's take a look at a couple of things. This is an inlet control thermistor and an inlet safety thermostat. What is the difference between those two parts? You got an answer, Jameson? Good thinking.
Alright, so inlet control thermostat.
Inlet control thermistor, inlet control safety thermostat. Just those two, for example. Can you read it now?
Alright, so
Much better.
the control thermostat is like it's control the airflow. It sends the airflow.
Thermistors, well, don't thermostats sense airflow?
Yeah.
No,
Control
the
the
inlet
board?
control thermostat.
Now, when they're sensing airflow, are they sensing the movement of the air?
No, it's sending message
No,
to the
no.
board.
The temperature.
They will send one message to the board for what?
Close open. Let them know how to close.
The thermistor opens and closes? What's the difference between a thermistor and a thermostat? Yes.
The thermostat
Since
reads the temperature of the dryer. What's in the dryer? The
What does the thermistor do then?
thermostat?
Reads the temperature of the dryer, right?
no.
I thought the thermostat control the temperature, and the thermostat reads the sense the temperature.
They both sense temperature. Yes.
I would think the control thermistor cycles the machine on and off as far as the heating element, and the safety thermostat is there to cut everything off should a temperature be exceeded.
Okay. Well, let's simplify it a little bit, and then, like I said, we're going to go through this book, and I'm not going to read word for word what the book says. You guys can all read the book on your own, but I'm going to identify the components. A thermostat is a switch that opens and closes on temperature. A thermistor is a resistor where the value changes on temperature. And whenever we have an electronic controlled machine that has to do with temperature, and a majority of our machines now all do that. Dryers, we have to heat the air. Washing machines heat the water. Dishwashers heat the water. ovens, heat the oven, refrigerators. You have to have sensors that tell these control boards what is the temperature, because we can't get too hot and damage the clothes, or not hot enough and not dry the clothes. So a thermistor is talking to the control board, and a thermostat is actually turning something on and off, like a switch, like a light switch, turn on and off. And we'll identify these components, okay? So here, I'll just take it off. Speed this up. So let's take a look here. So at the top of the machine here, we have the main control board. That's this board right up here, and we'll break all these components down. We have a thermistor, thermostat, and another thermostat over here. So we have a thermistor and thermostat in the top left. We have a thermostat on the top right on the heater housing. The very bottom of the heater here is where all the wiring is connected to the heater. And then we have a thermostat and a thermistor down on the bottom, sensing not only the air going in to the unit, also the air coming out. And we'll break that down too. Why so many sensors? Okay? And we'll talk about what the purpose of each one of them is. So let's move down a little bit and let's talk about the components. This is just a gas dryer. The only difference, instead of having an electric heater in the back, we have a gas burner in the bottom right-hand corner. Basically, all the components are pretty much the same. Their locations might be slightly different. Here is the control board. The bottom one is for a gas dryer. The top one is for electric dryer. Let's take a look at the board. And you guys can look at the schematic that I gave you. And the schematic is going to show you some components on there. If you look at the big rectangular box on the diagram. These are just terminal locations. This connector right here, CN110, is where the user interface, or this control board here. This control board here, as you press the buttons and everything, it has a ribbon cable coming off of it. And when you press buttons, this cable here is going to the main board here at the top and telling the board, oh, I pressed cottons, or I pressed time dry, or I pressed automatic dry, and then this board takes that message and it interprets it. Let's take a look at some of the components on the board here. Anybody know what that is? It's a speaker. You know when you press a button and it beeps, or at the end of the cycle it makes a noise? That's a speaker on the control board. We have here 1, 2, 3, what? What are these?
Relays.
Relays. What is a relay?
It's a switch and a coil.
Switch and a magnetic coil. That switch is controlled by the magnetic coil. When the coil gets powered, it opens or closes a relay. We got 1, 2, 3 relays. Anybody got any idea what those relays would control in the machine?
They control the heater.
Control the heating element?
No. Both control the heating. 2 of them control the heating element. 1 of them controls the motor.
Okay, that's good, but why do we have 2 controlling the heating element?
You got the inlet and the outlet here.
Inlet and the outlet heater?
Because the heater control about 240.
Now, if we look closely, Jawensky's right about that. Let me see if I got a good picture of that element here. The picture is not that great, but we have 2 wires over here, and we have 1 wire over here bringing power, but there's 2 elements running around the drum, and these 2 elements actually connect to 1 wire here, and these are 2 separate wires here. So I can energize just the heating element on the inside and not the outside, or I can energize both. Why would I have 2 different heaters?
High and low temperature.
High and low temperature, but don't the thermostats control high and low temperature, or the thermistor tell the board, hey, it's 120 degrees or it's 160 degrees, shut off? Well, this is right in back of the drum, and if it gets too hot and radiates too much heat, even on a low temperature setting from the controls, the panels in the drum could get so hot. Some delicate clothing, like silk or something that, that women wear, they could hit up against that hot metal panel and could damage the panel. So we can't have it get excessively hot. So on delicate clothing, we're going to put only one element on. And it's still going to reach temperature, it just takes longer to get there. So you could have a element be broken. Let's just say this outer element here is broken. What do you think the complaint from the customer would be? Yes.
My towels are not drying properly.
And what's not drying properly mean? Because not properly is
Longer dry.
it's taking longer to dry. But I said one element will still get to whatever temperature I need it, but it will take longer to get to that temperature with one heater than it does two heaters. So, you know, if someone tells you, yeah, it's taking me forever to dry, you're gonna take it all apart, start checking the heaters?
No, not the first one.
Check the board on
What was the first thing we talked about?
the power.
The power? No, the
I mean,
length.
the blower, the
The
dog.
airflow.
The airflow.
Yeah,
Then we're gonna go and we're gonna take the meter out if the airflow is good. If the hose in the back of the machine's blocked or the vent out the building's blocked,
it's black.
dryer could run all day and not dry. Yeah, am I gonna check to see if I have 240 volts? Am I gonna see if it gets hot?
Yep.
I mean, we're first gonna turn it on and see what it does before we start checking anything. But, I mean, how often have you guys worked on dryers and saw the hose crushed in the back or the machine not installed right?
Every single day.
Every day.
Every single
But,
day.
I mean, some people, when they first start fixing appliances, you know, and the dryer ain't working, all right, let's go to the heater. Tear everything off. Hey, the heater's good. Damn, I took this whole machine apart, and it wasn't that. So an experienced technician walks up, asks the customer a couple of questions, turns the machine on, sees what it's doing, and then based on that, we go ahead and say, okay, now I got an idea of what it's doing. Now let me start making some tests. That first few minutes of you interacting with the customer and just looking to see what it's doing is going to make your life so much easier. You know, I remember years ago teaching refrigeration, and I had a guy, he did everything in class, about ready to graduate, and I said, you got a refrigerator, now it's cooling, what's the first thing you do? He says, well, I'm going to hook up some gauges and check the pressure to freon. Well, refrigerators, do they have valves on them to hook up? No, you have to add a valve. And could that valve leak in time? You're going to pull the fridge out, put access valves on. What if it's not defrosting? What if the door gasket's not sealing? I mean, these guys are so gung-ho, I'm going to hook up gauges, I'm going to check pressures. You know, you have to take a few minutes. Don't throw tools on the machine right away and look and evaluate what it's doing, okay? So let's move on. Okay, so those are the two machines. That's the main board. That's just the user interface board. These little black dots here are a little hard to see. Those are the buttons on the face as you're pressing on the control board. Those are the actual buttons being made on the board. Okay, top panel, control board, I don't want to go through that. Front panel. Okay, this is really how to get into the machine. It's a little hard to see. I don't know if they're going to have a better picture here, but there's a switch right here. Does anybody know what that switch is for?
Where's that?
It's located underneath these wires. It's a little hard to see, but that switch is activated by this tension pulley.
The bell switch?
That's you hear me? You hear me clicking it? I can't see it. It's all the way down there. Sometimes it's either a pulley switch or a belt switch, depending on your manufacturer. It's all the same thing. That switch controls this motor. There's a wire here that runs directly to that switch. And if the customer belt break, the motor don't run. What would be the easiest way? Someone calls you out. You press start on the dryer. It's not doing anything. You open up the door, the light comes on, you know it has power, right? Mm-hmm. And that's enough power to get the motor to work. Maybe not enough for the heater, but you press start and nothing happens. Okay? Let's assume the belt switch is stopping the motor because the belt had broken. You're going to take the top panel off and check for the belt?
No.
What would be an easier way?
Turn the
Open the door up, stick your hand, spin the drum around. If the belt's broken, the drum spins real easy.
Mm-hmm.
If the belt's good, you can feel a little bit of tension. It still can turn, but you feel a little tension. And you have to be careful. Sometimes if you turn the drum the wrong way, what happens?
The belt comes off.
The belt jumps off. okay? And you have to go in there anyways.
Dude, like this.
Even if the belt's on, could the belt switch itself be defective?
Yes.
Yes. So just because the belt's on doesn't mean the switch itself is good. Let me see if I can find a better picture as we move on. Okay? So, let's go here. Notice the guy's wearing gloves while he's taking it apart, right guys? Mario, you got your gloves today, right?
No, not it. Let's start one of the whole of mine.
Okay, drum shaft bearing. The back of this drum has a shaft here, and this one has a nylon bearing, some of them don't. And this goes right through the back of the machine here in the middle here. There's a holder for that bearing. There's 3 screws here, especially the Frigidaire where you have the ball in the back. I've seen people when they go to work on the drum, the first thing they do is they remove these 3 screws to take the drum out. And when that happens, the back of the machine falls down, could damage something. And there's no way you can put those screws in while the drum's in the machine. You have to take it out. So to take this out, do it outside the machine. Take the drum out, put it in, and put it back together again. These also work on the back of some of the older GE dryers. There was a little metal piece outside the back of the drum, and it would touch up against the back of this drum. Does anybody know why they might have that on the back of some machines? It's just like a little bent, spring-loaded piece of metal, and it would just touch the center of this shaft.
Why they put it outside?
Why would they have that at all? To keep it from moving?
Noise?
Not noise. What happens when it gets real cold out and you rub your feet on the carpet and
Static electricity.
static electricity? And when you dry clothes and you got hot and cold air and real hot air and you create static electricity in your clothes. Have you ever had socks stick together or whatever? That's an actual ground that grounds out the drum, so it reduces the static electricity on your clothes. Pretty neat, huh? Okay, so let's move on. Okay, here's the idler arm. Still can't really see the switch too well. We're gonna move down. Now there's a better picture of the belt switch. You notice you can see the outlet, control thermistor, and control backup thermostat. And I'll talk a little bit more in detail of why we have inlet and outlet and why we have so many thermostats and thermistors in there. When they made these machines 20, 30, now almost 40 years ago, dryers only had 2 thermostats in them. They had an operating thermostat and a high limit thermostat. No thermistors, why? 35, 40 years ago,
board.
why did they have no thermistors?
You didn't have board.
We didn't have electronic control machines till the late 70s, early 80s. The 80s is when electronic machines started coming out, and the computer boards had to have a way to know the temperature. Okay? So, I lost track of what I was thinking, but we'll move on. So, when they started making machines, the thermostats were there to control the air coming in and the air coming out, because if we had an airflow problem inside the machine, one thermostat can see the temperature, the other won't. So we'll talk about that in the diagram. So this is just how to get in it. I'm going to move on. Here's how to take the heater off. Let's get to the actual electrical components. I don't want to talk about gas today. Okay, so inlet safety thermostat and inlet control thermistor. The actual sensing part of that thermostat's right here, so it's sensing the heat coming off the element. Those thermostats and this thermistor here are not supposed to control the temperature of the dryer. In other words, if I'm drying towels or I'm drying jeans or I'm drying t-shirts or something like that, and we have to be a specific temperature. Does anybody know the average temperature a dryer, a residential dryer, dries at? 250 degrees?
140.
That's almost boiling water.
140, I think, remember.
about 140 is average. The low temperature setting is about 120, 125. The high temperature setting is about 160. And we want to keep an average about 140 degrees in the middle, depending on what we're drying. Okay? But these thermostats and thermistors are a lot higher temperature. We'll find the settings and the temperature in there. The purpose of them is they're both there for safety. If the customer doesn't clean this filter out, and it's sitting right here, what's happening to the airflow?
Blocked.
It's not flowing. And we have a thermostat right here and a thermistor right here, but if I'm blocking the air coming in the fan, this thermostat will never see how hot it is. And if I block the airflow here, I don't have airflow over my heating element. And I need to have airflow over it. If I don't have airflow over it, that element gets so superheated it bends and it breaks. So these controls that are on the heating element itself are almost always there just for safety. And that's because if we have an airflow problem, the controlling thermostats that actually control the temperature we want to dry at cannot see the heat. Okay? So they cycle or they shut off based on that safety device there. Okay? So let's move on down. High limit thermostat. Look at that. High limit thermostat opens at 315 and closes back again at 250 degrees. So the temperature that thermostat cycles at is based on that. That's way too hot to dry clothes. But if it's getting that hot back there, you're probably having an airflow problem. All right? That here's a high limit thermostat right here. This is another one. And it's telling you the wires and how to get to it. So most of this is just how to get to it. This is our outlet control thermistor. Where is that one located? What's the first word?
Out.
Out.
So that's where the air is what? Going out. Before we were doing inlet. Remember at the beginning I said air comes in over the element. It goes out through the fan. So we're talking about down here on this housing down here. So the outlet control thermistor is the main one that's doing the job. That one there is telling the control board it's 140 degrees, turn off the heater. Okay? We have an outlet thermostat, and that's in case the thermistor doesn't tell the board properly, or the relay on the board, even though the board's trying to shut off, the relay contacts don't open up and don't shut it off. Okay? So let's move on down. We got the outlet control thermostat. So this is the outlet thermostat. That's this one that's located right here, right on the outlet.